In the last class, we learned 5 properties of definite integrals. In this class, we will learn 2 more. I have written down the first 5 properties that we learned in the last class. Now look at this and tell me, how is the first 5 different than the one that we are going to learn now? If you look carefully, you will see a pattern. In all the 5 of them, you will see that the limits ranges from A to B. Even when you interchange the limits, here what happens, what was the second property? We interchange the limits. The lower limit became the higher limit and the higher limit became the lower limit. But still it was A to B. What happened in the third property? We split the limit. We took a C which was lying between A and B and we split the limit. But even then it remained A to B. The limit as it is did not change. But then look at these two, look at 6 and 7. What do you have here? The limit, the question, it is ranging from minus A to A. But in the answer you see it is 0 to A. Similarly here, did you see this? It ranges from 0 to 2A. But here it is ranging only from 0 to A. Does that mean that this is something new? Not at all. What it is just a follow-up on these 3 properties. Now I am not going into the details of the proof, but it is very easy to see how we got this. See, minus A to A, they have applied this, the third rule, and done what? Taken a C in between. What have they taken? It is actually 0. 0 is always the midpoint of any A and minus A, right? Minus 4 and 4, minus 5 and 5. 0 is always the midpoint. So for sure it will lie in between A and minus A, right? So they have taken it at 0 and split this integral into 2. They have split it, one from minus A to 0, the other from 0 to A. And what we can prove is that the function acts similar. It is same value, same sign. From minus A to 0 and 0 to A, same sign. That is why you are getting twice of 0 to A. But then if it is an odd function, the magnitude will be same, but their signs will be different, which ends up in them getting cancelled and you getting 0. So it is nothing new. All we have done is a follow-up. It is an amalgamation of these 3 properties. You are getting this. The same here. Here what is happening? The same thing. 0 to 2A. Take a number in between. For sure A will be in between. Like 0 to 2A, A will lie in this. Then again split it and it happens the same way. You split it from one from 0 to A and the other from A to 2A. And if this condition is satisfied, what is this condition? If instead of X, you can put 2A minus X, then these two values will be same. So the whole thing ends up to 2 times this. But then if f of 2A minus X is equal to minus of fx, then these two integrals will have the same magnitude but different signs, which ends up in them getting cancelled. So you don't have to worry much about it. We are not dealing with the proofs here. We are just going to apply them in question. Now let us see how do even and odd function looks like. If in any function of x, instead of x, if you put minus x but you still get the same function, then this is said to be even. And in that case, what do you do? If it is from minus a to a, you can split the integral at where? At 0. Then you just need to integrate it from 0 to a into 2. This will give you the answer. Now give me some examples of even functions. Constant function is even. This is a constant function. You put x, you put minus x, still same. X square, x raised to 4, x raised to 6, etc. It just keeps on going, right? So what is an odd function? If instead of x, you put minus x, then the answer you get is the negative of fx. If f of x is equal to minus of f of minus x, then such a function is said to be odd. And in that case, what happens? If you integrate it from minus a to a, any negative number to the same of that positive, you will just get a 0. Now what are the odd functions? X, x cube, x raised to 5, etc. Now when it comes to trigonometric functions, there are only two functions which are even, that is cos x and sec x. The other four fall in this area. Why is that? Let us check. Here, this is the first quadrant, right? First quadrant, then here the fourth quadrant. When we say for example minus x, what does this actually mean? It means cos of 0 minus x, which means all the functions where instead of x, if you put minus x, they all fall in this region. 0 plus x will go forward, 0 minus x will fall in this area. So all the minus values you take, they fall in this area. So what are the only functions which are positive here? Here it is all positive. Here is cos and sec, tan and cot, and here. Okay. So this is the area where only cos and sec are positive. All the others, for example, sine of minus x is equal to what? It is minus sine x. What about tan of minus x? Again, that is minus tan x. All the other four, they are odd. So this brings us to the product of odd and even functions. If you find the product of two odd functions, what happens? Let us see. Suppose you have minus pi by 2, say x cube sine raised to 4x dx. So how does this behave? Look at x cube. What is x cube? It is an odd function. What about sine raised to 4? Now before we continue any further, please notice the difference between sine x raised to 4 and sine raised to 4x. This means sine of x into x 4 times. But what does this mean? This means sin x into sin x into sin x 4 times. So take the first function. Suppose f of x is equal to this. Then what is f of minus x? That is sine of minus x the whole square. But then sine minus x is what? It will be minus of sine x, because sine is an odd function. Now this is a negative number multiplied 4 times. Then what does it become? It becomes sine raised to 4x. So though sine x is odd, what have we done? We have multiplied it an even number of times. So what happens? This becomes even. So odd into even becomes what? It becomes odd. That means the answer is 0. Now let us see one more question. What do we have here? What is the first one? It is x cube, which means an odd function. Now you see the second, it is a product of two functions. One is odd, cos x is even, odd into even is equal to odd. So this is odd, this is odd. What about tan x? Now tan x in itself, suppose take f of minus x. So instead of x, put minus x. So what do you know? Tan x is an odd function. So that means this is minus tan x raised to 5. An odd number multiplied, an odd function multiplied an odd number of times. Forget tan x, take any number, just take 1. So minus 1 raised to 5. Minus 1 multiplied 5 times will again be what? It will again be minus 1, right? So the minus sign is retained. That means what? This is also an odd function. So the first function is odd, the second is odd, and the third is also odd. So now what do? We can split the integral, and then we can take all of the odd, it becomes 0. All we have to worry is about this one. What happens to the limit? The limit, we start from half, from here, from 0. From 0 to pi by 2, and do not forget the 2 here. That means 2 into, so the answer will just be 1 pi. So this is your answer. So the first one you see here, I am not going to do this because it is very clear. Sine function is what? It is an odd function. Then an odd function multiplied an odd number of times ends up as an odd function. So this whole thing becomes 0. What bothers us is this. This is an odd function multiplied an even number of times. So how do we solve this? We have already proved that it is even. Why is that? Sin x may be an odd function, but it is being multiplied an even number of times. So it becomes this. This is 2. Now, if you take this as I, let us take this as I. What is the other way you can represent I? The same thing, 0 to pi by 2. And instead of x, if you put pi by 2 minus x, remember we did an entire session in the last class. So that becomes cos square x dx. So add both the equations, you get 2i is equal to 2 into 0 to pi by 2 sine square x plus cos square x. That is equal to 1. So if when you integrate 1, you get x. Again your answer is pi. I is equal to pi by 2. And so far we have been directly applying the properties. We just apply one property and we will get the answer, right? Now we will move on to step problems where you will have to apply more than one property. We will see how that works, and trust me, you also try doing it, and as you see me working out the solution, you also try doing it. If you want, you can apply any property. As long as you apply the property correctly, check the limits, check the function. If you see how a function behaves in a certain way, if you apply it correctly, trust me, there are 100 ways to do every question. You see here, I have written down 3 questions, right? But they all have the same answer. You start with any one, at some point you will come to the other 2 questions. So this appears as 3 different questions in textbooks. But I have put all of that together because they all have the same answer. We will start with this. Suppose I is equal to 0 to pi by 2 log sine x dx. Then instead of x, you can substitute what? Pi by 2 minus x. You remember that property that we learned? Sine pi by 2 minus x will be what? It will be cos x dx. So see, you have got the second question. Anyways, you get 2 values for I. So 2i is equal to what? 0 to pi by 2 log sine x plus log cos x. Now, what do you see here? If you just get a 2, you put a 2 here. See, that is your third question. So that is what we are going to do. You can't just put a 2 here, right? That is not possible. So what do? It is inside the log. So you can't just add a 2 there. Then again, log a plus log b is equal to log a into log b. See, there. Now you can put all of this together, and what will you get? 2 log a plus log b, log a into b, that is 2 sin x cos x, which is what? Sin 2x. We have got our third question also. All the 3 questions are covered in this one. But then this we will deal separately. We are just concentrating on this. We will find this answer and substitute in that equation. Now look at these 2. You remember what we started with? The first ever property. Did you remember? Do you remember that? Same limits, same function, then they are equal. So we will try to do that. We already have got the limit same. We will try to make the function same. This is log sine x, but this is log sine 2x. What if we take this 2x to be theta? Then what will happen? Suppose you take 2x is equal to theta, then 2 into dx is equal to d theta. But then what happens? The Limits also change. X is from 0 to pi by 2. So 2x, which is theta, will be from 0 to pi. So what do you have? You have 0 to pi log sin theta d theta, but a by 2. That by 2 will come here. Now what has happened? We have got log sin x dx, log sin theta d theta, but now what has happened? Look at the limits, 0 to pi by 2. Now this is 0 to pi. How do we reduce this to 0 to pi by 2? This brings us to the last one. We are trying to get the first property. Now we are going to apply the last property that you learned. What was it? If a function is being integrated from 0 to 2a, then check whether instead of x, if you can substitute 2a minus x. See if you can do this. If you can substitute, then what will you have? You can take this, it does not have to be 0 to 2a. It just has to be 0 to a fx dx. But then if this is not equal to fx, instead it is minus of fx, then this whole thing is going to become 0. So let us check that. Let us check it if it is equal to fx or minus fx. Log sin, what is 2a? 2a is pi. Pi minus theta. Now where does this lie? 0 pi by 2 pi. Pi minus theta. So it lies in this area where sine is positive. So this becomes positive, and whenever you have pi, the trigonometric ratios are retained. Sine is sine, cos is cos. But at the same time, if you have pi by 2, 3 pi by 2, sine becomes cos, tan becomes cot, etc. So now here you get log sine theta, or in other words, instead of x, you can substitute it with 2a minus x, then you can get this, and it is possible. We have learned that. Now what do you do? 2, right? Into 2, 0 to a. If 2a is pi, then a is pi by 2 log sin theta d theta. So what have we done? We have finally arrived at what we started with. So what is this? This whole thing is equal to I. Now we can substitute in the original equation. We equated it to this. So that is the function that we started with. We equated this minus, this is log 2, and when you integrate you will get an x, and in that x if you put pi by 2 minus 0, you will get log 2 into pi by 2 equal to minus log 2 minus pi by 2, minus pi by 2. This will be your answer. Now here again it looks like two questions, but they are the same question. One of them pops up in the solution of the other. Just brush up our inverse trigonometric functions. Cot inverse of x is equal to tan inverse of 1 by x. It is not just for cot and tan. For sine also it is the same, cos also it is the same. You will have cos inverse of x is equal to, what is the inverse of cos? It is secant, right? So this is equal to secant inverse of 1 by x. So all the three trigonometric functions, they follow the same rule. Cot inverse of x is equal to what? Tan inverse of 1 by x. So see, we have come here, and whenever you have such tan inverse questions, whatever is inside this bracket, try to express it in two ways. Either a plus b by 1 minus ab, or tan inverse of just the signs, interchange the signs, a minus b by 1 plus a into b. So always try to bring it in this form, such that the numerator, try to express the numerator as the sum of two numbers, and the denominator, just this term, leave the one there, just take these two, minus x plus x square, so that you will get it in this form. Then what? Once you get it in this form, then what? then this is equal to tan inverse of A plus tan inverse of B. And this will be tan inverse of A minus tan inverse of B, and this is the same for tan also. It is first fact there. This is what you get. Now we have our answer, right? So let us write it down, x and 1 minus x. So that is equal to what? 0 to 1 tan inverse of x plus 0 to 1 tan inverse of 1 minus x dx. So you remember the law that we learnt, if instead of x what can you do? You can substitute it with 1 minus x. 0 to 1 tan inverse of x dx, and this also reduces to 0 to 1 tan inverse of x. Now let us find the answer. So this is your answer. With this question, we come to the end of this topic. So far we have seen all types of functions, trigonometric functions, logarithmic functions and exponential functions. What we have is a general function, just f. It can be anything. So this is a case which is given. This is a fact which is given. If instead of x, you put a plus b minus x, it is same. You don't have to integrate it for x to be equal to a plus b minus x. Even without integration, these two are same. Then we have to prove that this equality holds. Or in other words, the LHS is equal to the RHS. Let I is equal to a to b x fx. So applying the rule, what do? We can substitute wherever you see x. Instead of x, you know, by the property, we can substitute it with the sum minus x. But then you see, this is what we started with. This was our original I. We just got it again. That means I is equal to so when general functions are given, it is very easy. You don't have to know any formula. Like for sine or cos, there is so much formulas that you have to learn, how they behave in pi by 2 to pi or all of that. But this is a general function, so all you need to know is the property, apply it and you will get the answer. With this we come to the end of this class. Till I meet you again, you stay safe. Assalamu alaikum.